This is RTP. This is RTP180.
Well, thank you so much. Can you all hear me back there? So I don't know how one follows such a welcome, but I'm going to do my best. I'm going to need you guys in the front to help me, because if I fall off this thing, that would be very bad. So if I'm getting close, I need some kind of hand signals. Perfect. Thank you. You are hired. So yeah, that's me. And as Wade said, I am a teaching professor at NC State University, and my job is to teach people organic chemistry. I also direct the organic chemistry labs, so when I'm not teaching lectures, I'm training TAs and teaching labs, and that's, as you may imagine, a lot of fun. I do have a mission in life, and my mission in life is to teach people who are not chemistry majors more about chemistry. And so the title of my talk today is going to be all the chemistry that you already know, and I'm not necessarily talking about you all, because I've met some of you, and I know you know a lot of chemistry. I'm talking about all the chemistry that my students know when they come to me, and how we use that to further their knowledge, okay? So, as I told you, I do have a mission, and my mission is simple. I teach chemistry to non-majors and to chemistry haters. Lots of chemistry haters. And to all comers, really. I will teach chemistry to anybody that shows up. So why do I do this for a living, you might ask yourselves? Well, it turns out that at NC State, we teach a lot of people. Not just our majors, because we really are a small department. We graduate about 50 majors a year. But a lot of other people that come to us for all their chemistry needs, which average about 7,000 students a year. And we are a department that has less than 40 faculty. So as you may imagine, we teach a lot of classes. A lot of those people don't necessarily come to us wanting to be chemistry majors, or even being those people that are really interested in doing well in chemistry, like your pre-professional majors. A lot of those people simply fall in this category, okay? The chemistry haters. They don't necessarily love chemistry. They may not have had the best experience in high school, or maybe their high school didn't even offer a lot of chemistry classes. And a lot of them, when they come to my class, I teach the one-semester organic chemistry class, which in some places is called a survey course. And when students come to me, some of them have attempted organic chemistry before, and that didn't go so well. Sometimes more than once. So it is a challenge, and it is a challenge that I actually accept willingly. My research is in chemistry education, and my specialty is non-majors. So I'm not telling you this because I want you to feel bad for me. I'm actually perfectly happy with this situation. But I'm telling you this because I need to set the stage for what follows, okay? So there's where we are. And those are actual students who were not hurt in the making of this overhead, and who consented to be on screen for you all today. So the first question that I asked myself when I started this research project was the obvious one. This question was not that obvious to me, actually. This is a question that my students made me ponder about. And the question was, is chemistry a hard subject? And so if we can do a show of hands, if you think chemistry is a hard subject, could you please put your hand up? I see you, people back there. I see you. So there's a lot of hands going up, right? It is a hard subject. It is the central subject, the one that covers just about everything. And we hit people with general chemistry their first semester in college, and we tell them that they have to learn a whole bunch of stuff. And so this project started with some surveys where we asked people, is chemistry a hard subject? And if so, why did you say that? And what they said to us can be distilled into these two things, okay? A lot of people feel that chemistry is taught as a series of disconnected principles. And if you think back to your first general chemistry class, that's probably true, right? We talked about atoms, and we talked about bonding, and then we came up with things like electrochemistry and kinetics and all kinds of things that had nothing to do with one another. And that's general chemistry experience for most people. And then we do one more, besides teaching you disconnected principles, we ignore your prior knowledge whenever it's convenient to us. What do I mean by that? We usually start general chemistry assuming that you know what atoms are and electrons and protons and things like that. And we assume that you know as much about that as we do, which may not necessarily be true, right? But we also ignore any knowledge that you might bring to the table that might be useful. We teach chemistry as if you were a blank slate that knows a lot about chemistry. And that's really not helpful for everybody. A lot of people struggle with that. So the question that drives this research is this one. How much chemistry does an average person know? And by an average person, I don't mean you guys, because I've been around RTP before, and I know that y'all are kind of nerdy, and you know a lot about science, but put yourselves in the shoes of my students, okay? I'm teaching freshmen and sophomores. They just came into school. They're coming from all corners of North Carolina, and they all have some basic knowledge, but it may not be the knowledge that you guys have, okay? So if you want to play along, here's a question for you. Let's find out. Using only common kitchen equipment, can you estimate the proportion of water to gasoline in this bottle? I'm going to give you 15 seconds to talk to a neighbor and figure out if you can estimate that using common kitchen equipment. In case you can't see it, the line is right here, okay? The bottom is water, the top is gasoline. Go. Okay, and that was your 15 seconds. So how are we going to separate that water and that gasoline? Just somebody shout an idea, make it count. How are we going to separate it using kitchen equipment? How are we going to decide how much water and how much gasoline is in there? It's already separated, that's true. How do we decide what is the proportion? Measuring cup, right? You measure it, you use a measuring cup. A lot of students come up with the idea of using a measuring cup. It depends how you set the experiment, but most people know. How did they know? Because the concept of polarity is very popular. And we know what polarity is, even though nobody has taught us about it. We know about it because we have cooked things, we have eaten things, we have used fossil fuels. If you were raised in the South, I'm sure at some point you had to separate water from gasoline. But we can expand that concept to describe polar and nonpolar functional groups if we start there. So if you open a class by asking people to do a simple separation like that, and then you ask them to expand those concepts, you can get a lot done in a single day. So for example, you can talk about hydrocarbons and alcohols and how gasoline is composed of hydrocarbons. It turns out that people know a whole lot about gasoline, and alcohols are very similar to water. So alcohols kind of bridge the gap between polar and non-polar materials. Alcohols are very interesting, as we all know. Am I right? So here's a simple exercise. How polar are these compounds? How polar are alcohols? Can you mix alcohols with water? Can you make a rum and coke? Yes. What proportion of alcohol can you mix with water? Is there a limit? Because I haven't found it yet, right? So my students know those things because guess what? They have tried this at home. So when you use these concepts, you can get them to work with you, and you start from a place of knowledge, and then you build on other things. So the student outcomes from this project, these are actually happy students in organic chemistry class. I kid you not. The students felt empowered, they used prior knowledge in making new connections, and they start to trust their own results because they're coming to them from a place of knowing, which is really a very encouraging result for all of us that have been involved in this research. So I want to thank you for listening. I'm going to thank Wade for not coming with the hook, and thank you all.